Hi, welcome back to the 6th session in the Introduction to Programming for Teachers course. Once again, I'm Luke, and today we're going to be talking about loops. So what are the goals of this chapter, so this session and following sessions? It's to implement something called a while loop, as well as to hand trace the execution of a program involving a while loop. So what is a loop? What is a while loop? What's the point of them? Well, quite often in programming, we repeat some steps. We don't do something once, we do it multiple times. And it's much more useful to do these repeated steps multiple times using a loop than having to write out the multiple steps over and over and over again. Right? That becomes quite annoying. Using things like while loops, which we're going to look at, as well as something called a for loop, we can repeat steps really easily and really quickly. Okay, so some examples of where we might be using a loop. If we were calculating compound interest, so you're working out something to do with your money and the interest you're earning. Video game loops are really, really important. If you're working out the average of something, they're used quite commonly across almost all programs. So let's focus initially with this compound interest algorithm. We're going to start the year value with 0. Right, this is our initial point, and because we're computer scientists, we index from 0. So year 0 at the start. We have a column for interest, which is currently blank, and we're starting with a balance of $10,000, which is quite a lot of money. And then we're going to repeat some steps. Okay, so this is kind of the loop idea of repeating things. So repeat the following steps while, this is our idea of a while loop, while the balance is less than $20,000. So we're going to add 1 to the year. We're going to compute the interest as balance times 0.05, so we're getting 5% interest, which is quite a lot. And then we're going to add that interest to our balance, because not only are we getting the interest is actually increasing the overall amount of money we have. Okay, this is going to repeat over and over and over again, these steps. We're going to repeat over and over and over again while our balance is less than $20,000. Once our balance is no longer less than $20,000, we're going to report the final year value as the answer, so the number of years it took us to get up to that $20,000. Okay, so here is kind of our planning of a while loop. Now we can look at it both as a flowchart as well as a Python program. So we come into our flowchart at the top. Is the balance less than target? Well, if it isn't, if we've already made $20,000, we have a false and we exit our loop section. Otherwise, our balance would be less than target. So let's say we start with 10,000 and we're trying to get to 20,000. 10,000 is less than 20,000, so we follow the true arrow, which tells us we increment the year. We then worked out the balance and worked out the interest and added that to the balance. And then we go back to the start of the loop and check, have we hit our target? If we haven't hit our target, we increment the year, we calculate our interest and add it to the balance, and then we check if we've hit our target. And we keep repeating this loop over and over and over again, until hopefully at some point this condition becomes false, so our balance is greater than our target, and we exit the loop. Okay, as a Python program, we have it here in this grey section. While the balance is less than the target, so this is kind of this condition and the loop section, year equals year plus 1, which is this increment year. Add interest to balance becomes interest equals balance times rate divided by 100. And then balance equals balance plus interest. So we work out the interest in this line, and then we add the interest to the balance in this line, and then we repeat. Okay, that's the while. And you can see that the steps to include or to be repeated are indented one tier so they are inside the while loop. Okay, so here's some of the syntax of a while loop, of a while statement. So we initialize our variable outside the loop, and that gets updated inside the loop. So we initialize our value of our balance, the amount of money we start off with as 10,000. That initialization happens outside the loop. And then we have while balance is less than target, do stuff. Okay, so we end with a colon. Okay, just like we ended our if statements with the colons and our else if statements with a colon. The statements in the body of the compound statement must be indented to the same column position. Okay, so this section here is indented one tier. So these two statements are going to be executed over and over and over again while this condition is true, whilst the balance is less than the target. If the condition never becomes false, if our balance is always going to be less than our target, we have something called an infinite loop, which we'll talk about later. And we're also going to talk about this idea of an off by one error. Okay, they're quite common when using loops. Okay, so let's look at the execution of our loop. So here is our Python program. While balance is less than target, year equals year plus 1, interest equals balance times rate divided by 100. So this is calculating our interest, and then updating our balance. Balance equals balance plus interest. So step 1 is to check the loop condition. Is balance less than target? Well, our target value is $20,000, and we start with 10,000. 10,000 is less than 20,000, so the condition is true. So then part 2 is to execute the statements in the loop, and they happen in order. So we increment the year, so year equals year plus 1. Year was 0, now year is 1. 0 plus 1 is 1. Then we calculate the interest, so we have our balance, which is 10,000, times our rate divided by 100, and we're getting a 5% return, so that calculates to come out as £500, or $500, sorry, of interest. And then we hit the third line here, which is balance equals balance plus interest, so we take our $10,000, we add on the interest we just calculated, which is $500, and update our balance variable, so now it's $10,500. Okay, that is now complete. We've completed the contents of the loop, so we now need to check the loop condition again. Is our balance, which is 10,500, less than our target value? Well, 10,500 is still less than 20,000, so the condition is still true, and we're going to have to run the year equals year plus 1, the interest line, and the balance line again. Once those have completed, we're going to check our condition one more time. We're going to keep repeating this over and over and over again until this condition is false. Okay, so after about 15 iterations, we get, well, exactly 15 iterations, we get to the point where our balance is $20,789.28. This is now greater than $20,000, so balance is no longer less than target, and we get a false here. Okay, our condition is false, it is no longer true, so we no longer run the code that's indented and contained within the while loop. We skip to whatever would be the next line of code somewhere down here, and in our case that's print year, and we print the value stored in the year variable, which is 15. So we've calculated that if we start with $10,000, we get a 5% return, 5% interest on that $10,000 each year. Compounding the interest, it would take us 15 years to reach over $20,000. Okay, so about 15 years to double our money. So as a full Python program with nice comments and properly laid out and named variables and using constants and so on, we have a constant rate of 5%. We have an initial balance, which is a constant of $10,000. We've got our target, which we're saying our target is to double our money, 2 times our initial balance, so $20,000. The balance that we're going to update over and over and over again, we're going to call balance, lowercase letters because it's going to keep changing. And we're going to set that to our initial balance. And our year variable, which is going to keep track of how many years we have our investment going, is going to be set to 0. We're declaring and initializing all of these variables outside the while loop. Okay, not inside the while loop here, but outside, so they have initial values before we go into the while loop. Then we have our while loop, and what it's designed to do is to count the number of years required for the investment to double. So while balance is less than target, year equals year plus 1, interest equals balance times rate divided by 100, balance equals balance plus interest. So every time we go through this loop, we're going to be calculating some interest, we're going to be adding on that interest to the balance, and we're going to be incrementing our years. Eventually, hopefully, our balance is going to be greater than our target. We will exit the while loop and run the next line of code, which would be on line 19, which there's nothing. There's a comment on line 20, so line 21, we're going to print the investment doubled after the value stored in the variable year, years. And our output, unfortunately, is kind of underneath this grey box. It says program run, the investment doubled after 15 years. So you can pause the video here. You could copy this program down, use the correct typing, formatting, constant variables, uppercase letters, CamelCase, for everything else, run the program, and check if your program agrees and gives you the same output. And it should give you the output, the investment doubled after 15 years. Be a little bit careful. You might get some errors based on, spelling mistakes or improper indentation, things like that. Just carefully copy it down, give it a run, and hopefully you'll see it working. So here are some while loop examples. These are interesting things to look at, and they indicate quite a few errors that commonly occur. So let's start at line 1, or the first row, I guess. So we have I equals 0, total equals 0, while total is less than 10, I equals I plus 1, total equals total plus I, print I comma total. Okay, so initially I is 0 and the total is 0. So while total is less than 10, well, total is 0 here. So 0 is less than 10, so that's true. So we're going to enter into our while loop. I equals I plus 1. So we get I is 0, so 0 plus 1 is 1. So I is now 1. So we've got a value here for I. Total equals total plus I. Well, total was 0. I has the value 1. So 0 plus 1 is 1. And then we're going to print out our I value currently, which is a 1, and our total value, which is also 1. So our first printout is 1, 1. We then go back to the start of our while loop. Our total is currently 1. 1 is less than 10, so we run the lines, or we execute the lines contained within the while loop. So I equals I plus 1. Well, I was 1, so 1 plus 1 is 2. I is now 2. Total equals total plus I. Total is 1. I is 2. 1 plus 2 is 3. Okay, so total is now 3, and we print out I comma total. So we're going to print out 2 for I, and the value stored in the variable total is 3. We go back to the start of our while loop. 3 is less than 10, so we run we execute the code contained within the while loop. I equals I plus 1, so I is 2. 2 plus 1 is 3. Total equals total plus I. Total is 3. I is 3. 3 plus 3 is 6. So we update our total to 6, and then we print out 3, 6, our value I, and the value stored in the variable total, which is 6. 6 is less than 10, so we execute the code contained within the while loop. Okay. I is 3, 3 plus 1 is 4, so now I is set to 4. Total is our previous total, which was 6, plus our I value, which is 4, so we get 6 plus 4 is 10, and we print out our I value, which is 4, and our total value, which is 10. We go to the start of the while loop. Is 10 strictly less than 10? No. This is now false. We stop running the code in the inside the loop, and our loop ends. Okay, so this program would run, and the output you get on your Python shell would be 1, 1, 2, 3, 3, 6, 4, 10. It's worth maybe pausing the video, having a little play of that, run it through, check that it agrees with how you think it should work based on the description you've just had there. Okay, if we look at the second row, it seems to look like a very similar program. I is 0, total is 0, while total is less than 10, I equals I plus 1, but this line here has changed. Total equals total minus 1, so we're no longer adding on our I value, we're taking away 1. Okay, and then we put. So let's run it through maybe. I equals 0, total equals 0, while total is less than 10. 0 is less than 10, so we enter our loop. I equals I plus 1, so 0 plus 1 is 1, so I is 1 now, and our total is our previous total, which is 0 minus 1. 0 minus 1 is minus 1. So our total is now minus 1, and we're going to print out our I value and our total, which is 1 minus 1. Okay, we go back to the top of the while loop and check the condition. Minus 1 is less than 10. That's true, and we run through the loop again. We increment the I value, and we take away another 1 from our total. Okay, and we're starting to have a problem here, because we're going to keep taking away and taking away and taking away from our total. So our total is never going to increase. So our total is never going to get bigger than 10. Okay, so we're never going to exit this while loop, and this is going to cause us to have something called an infinite loop, which is a problem. One of the things you might have noticed here is actually this output column here is false. It's not correct. The author wrote thinks that this -1 is actually a -I. So they're constantly taking away an I, which is why they've got 1, 3, 6, 10, -1, 3, -1, -3, -6, -10. They've actually just written down -1. So if you run this through by hand, you're just going to get -1, -2, -3, -4, and so on. But again, it still gives you an infinite loop. You never get bigger than this 10 value because you're always getting smaller. You're always taking away 1. Okay, if we look at row number 4, again, fairly similar program. I equals 0, total equals 0. While total is less than 0, I equals I plus 1, total equals total minus I, print I comma total. This isn't going to output anything. Okay, if we run it through, I equals 0, total equals 0, while total is strictly less than 0. Well, 0, the current value of total, is not strictly less than 0. So this while loop never runs, so we never hit this print statement, so we don't output anything. Okay, the statement total less than 0 is false initially, the first time it's checked, so the loop is never going to be executed. So we get no output from this third row. Okay, if we look at the next row on this page, I equals 0, total equals 0. Whilst total is greater than or equal to 10, I equals I plus 1, total equals total plus I, print I comma total. Well, again, we're going to have no output. If we run it through by hand, while the total is greater than or equal to 10. Well, 0 is not greater than or equal to 10, so this is a false. So we don't run the program the code contained within the loop, and we produce no output. So what's probably happened here is the programmer thought they're going to stop summing up their values when they hit 10. But that's not really what they've written here in their condition. Okay, so the condition controls when the loop is executed, not when the loop ends. Okay, if we look at the last one, I equals 0, total equals 0, while total is greater than or equal to 0, I equals I plus 1, total equals total plus I, and then not within the loop, okay, because it's back in indentation level, we get print I comma total. Okay, so I equals 0, total equals 0, while total is greater than or equal to 0, 0 is greater than or equal to 0, so we enter our while loop, I equals I plus 1, total equals total plus I. Okay, so initially we've got a total now, an I value of 1, because we've incremented it, and a total value of 1. Go back to the start of the while loop. 1 is now strictly greater than or equal to 0, we increment I, we increase the value in total, we check the loop condition. Okay, our total is going to keep increasing over and over and over again, so it's always going to be greater than or equal to 0, so we're never going to exit this while loop, which means we're never going to hit this print statement, because the print statement is outside the while loop. Okay, so there's no output, and the program's not going to finish. Okay, and as an explanation, because the total will always be greater than or equal to 0, the loop runs forever, it produces no output, because the print function is outside the body of the loop, as indicated by the indentation. These two lines are inside the loop body, this one is outside. So the kind of common errors that we often see are don't think, are we there yet? So the loop body will only execute if the test condition is true. And this kind of goes back to this idea here of the programmer probably thinking stop when the sum is at least 10. However, the loop condition controls when the loop is executed, not when it ends. Okay, so are we there yet should continue if false. We're not there yet, 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 we're not there yet. So if the balance should grow until it reaches the target, which version do you want to use? Do you want to use this version here on the left, or this version here on the right? Okay, have a little pause of the video, have a little think, maybe run it through with the test example by hand. Which one of these do you want to use? Remembering that you're wanting your balance to grow until it reaches the target. Okay, so let's look at this one on the left-hand side. While the balance is greater than the target, run the loop body. Okay, so if the balance is initially less than the target, this condition is never going to run, right? This condition is going to be false. The loop body is never going to run. The balance is never going to increase. So if the balance is less than the target, it's never going to increase because we never run the code. So we're never going to grow until we reach the target. If the balance is already bigger than the target, then we're going to enter the loop, and then we're going to keep increasing the balance over and over and over again, and in fact we're going to have an infinite loop. So this isn't the one we want. We want this one on the right-hand side, where if the balance is less than the target, we're going to increase the year, we're going to increase the balance by calculating the interest and adding it on, and then we're going to check. And this is going to happen over and over and over again until we reach the target, until we're bigger than the target, at which point this condition will be false. We're going to exit the loop. So we want this one on the right-hand side. Okay. Common error, the second common error is infinite loops. Infinite loops happen more often than you'd be surprised because of slight mistakes. So the loop body will execute until the test condition becomes false. So what happens if you forget to update your test variable? What happens if you forget this line at the bottom? Right? Imagine this line isn't here. Bal equals bal plus interest. Imagine that our code is just this top chunk. Okay? So balance is our test variable, and the target doesn't change. So let's say our balance is less than the target. We enter our loop. Year equals year plus 1. Interest equals balance times rate. At no point have we changed the target we're trying to reach. At no point have we actually changed the balance. So we go back and we check again, and the condition is still true because we haven't changed anything. So we increment the year, we work out what the balance is, what the interest is, and then we go back to the start of the loop, right? Because this line we've missed out. Okay. We're never updating the balance. We're never changing the target. This condition is going to repeatedly evaluate to true, and we're going to end up running an infinite loop. It's going to repeatedly happen over and over and over again. It's not going to stop unless we physically stop the program. Okay? So we need to remember with our loops to make sure that we update our test variable. We update this case, right? Hopefully the program should stop at some point. Most of the time you do not want an infinite loop. Okay, so the final common error we're going to talk about is off-by-one errors. And off-by-one errors happen all the time. Even with experienced programmers, because it turns out counting is actually quite hard. So probably more so than the previous two common errors, this is one that you're going to keep making mistakes with. I still make mistakes with it all the time. Typically, when we're using a while loop, we might use a counter variable, right? And a counter variable is used as the test condition to see how many times we want to do something. And you can start your counter variable from whatever you want, but typically people start it from 0 or 1. Programmers, because they index from 0, often start the counter at 0. So if you want to paint all of your 5 fingers, for example, and you start counting at 0, when are you done? Well, you go 0 is your first finger, 1 is your second finger, 2 is your third finger, 3 is your fourth finger, and 4 is your fifth finger, right? And that's quite confusing because you're starting at 0, so you're going to be ending up using a less than operator and counting the number of fingers you've actually painted versus the number of fingers you want to paint. Right? So while finger is strictly less than fingers, paint a finger, finger equals finger plus 1. So we paint our first finger, our second finger, our third finger, our fourth finger, and then our fifth finger. But we've actually only counted from 0 to 4, even though we're trying to get up to 5 fingers. Okay, and we need to use the strictly less than symbol. If we start counting at 1, right, we need to not use this less than symbol, we need to use a less than or equals to symbol. Right, we start counting at 1, okay, we paint our first finger, our second finger, our third finger, our fourth finger, and we run it a fifth finger time because we're using this less than or equals to symbol. Okay, finger will equal 5. Okay, so off-by-one errors are quite common, especially when we think about maybe indexing things, if we're thinking about strings starting from 0. So just be careful based on what you're counting, where you should start from and which symbol you should use. Should you be using less than? Should you be using less than or equal to? Okay, I make this mistake all the time, and quite often I have to go back through my code and make changes to make sure that I'm counting properly. Okay, one of the ways that we can get much better at understanding how a while loop works is to trace out the while loop by hand, right? So what I would suggest everyone does is get a piece of paper and a pencil and draw a table like this, right? A table for your I value and a table for your total value, because our code is going to use an I variable and a total variable. Okay. And the question might be, here's a piece of code. What does the piece of code do, right? And you could work out what the piece of code does maybe by looking at it. Maybe you'd want to go and run it on a computer, but we're going to do it really, really fundamentally slowly and in a lot of detail to properly understand what is going to happen in every single iteration. And we're going to do that using a pen and paper and using this column. Okay, so draw a column with each of our variables, our variable I and our variable total. Okay, so we're going to start off with our initial values in the table. I equals 10 and total equals 0. Okay, so we've done line 1, we've done line 2, line 3 is blank, and then we get to line 4. While I is greater than 5. So I is 10, 10 is greater than 5, so we move on to the next line of code, which is total equals total plus I. So our total is 0, 0 plus I is 10, so 0 plus 10 is 10, so we cross out the value held in total, and we update it with its new value, which is 10, and then we move on to the next line of code, which is I equals I minus 1. So I is 10, 10 minus 1 is 9, so our new I value, we're going to cross out that 10, and we're going to write a 9 in the next row. Okay, what you can do is you can use a paperclip alongside the code to kind of move it around to make sure you're doing every single line in the correct order. Okay, so execute the code statement by statement, keep track of where you are, maybe with a paperclip, and then as you update the values of the variables, cross out the old value and write down the new value in the next line. Okay, I'm going to give you guys, I think you should probably stop the video here, pause the video, try and keep running through this program, keep updating the table until at some point, hopefully, the while condition here is evaluated to false and you get to this print statement at the end. Okay, so step by step, line by line, pen and paper, run this code. Once you've done that, unpause the video and we'll move on to the next section. So after 4 iterations, if you've done this, so we are now testing our condition for the 5th time. Okay, we tested it for I equals 10, I equals 9, 8, 7, 6, right? Our table is going to look like this. I is still larger than 5, 6 is still larger than 5, so we go around one more time. So total equals total plus I. Our total is 34, our I value is 6, so we get a value of 40 out, and we have I equals I minus 1, so 6 minus 1 is 5. So we're going to have 5 and then 40 in this column, in that row. And then we move on to kind of the next iteration, which is to check the while condition one more time. So after 5 iterations, we're now testing the condition for the 6th time. Our table is going to look like this. I is now 5. 5 is not strictly bigger than 5. So this condition is false. We exit the while loop. Our paperclip jumps down to this print statement at the bottom, and we print the value of the total, so we print 40. Okay, so that's an example of hand tracing. I really like hand tracing. I think it's really useful to initially understand loops, and some harder code that eventually you might read or you might try and write. Again, you might come back to hand tracing maybe if you've got a loop within a loop, something slightly more difficult that you need to keep track of. Okay, so a quick summary of the while loop to end the session. While loops are very commonly used. You need to remember to initialize your variables before you test. Okay, if you remember all the way back to the balance, the interest problem, we initialized all our variables before starting our while loop. The condition is going to be tested before you run the loop body, right? You have to enter the loop before you run the loop body. This is called the pretest, and then that condition can often use a counter variable. If you're using a counter variable, be careful about off by 1 errors. Something inside your while loop should change one of the variables used in the test. Okay, if we don't change one of the variables used in the test, we're going to end up in one of those infinite loops that we talked about, and I think that was our 4.2 error, common error 4.2. Okay, so watch out for infinite loops and watch out for off by 1 errors. So that was session 6 in our program. Session 7 again will continue with while loops and some more complicated concepts. Thank you for watching. Try and do the problem sheet as well, because that'll give you a better insight of how to run these pieces of code and how to write programs.